On today's video, we're going to use a special product, which is sum and difference of two terms. To solve for the sum and difference of two terms, or SDTT, we write it as quantity E plus 3, quantity E minus 3. This is our easy question. To solve for this using SDTT, we follow the following steps. First, square the first term. It then becomes quantity E squared. Second, square the second term. It then becomes quantity 3 squared. Third, take their difference. It then becomes quantity E squared minus quantity 3 squared. The final answer then is e raised to the second power minus 9. That is the answer to our easy question. Now, for our average question, we write it as quantity 4a raised to the second power plus 2 quantity 4a raised to the second power minus 2. To solve for the SDTT, we follow the following steps. First, square the first term. It then becomes quantity 4a raised to the second power squared. Second, square the second term. It then becomes quantity 2 squared. Third, take their difference. It then becomes quantity 4a raised to the second power squared minus quantity 2 squared. The final answer then is 16a raised to the fourth power minus 4. For our challenging question, we write it as quantity z plus k plus 10 and quantity z plus k minus 10. To solve for this problem using SDTT, we follow the following steps. First, square the first term. It then becomes quantity z plus k squared. Second, square the second term. It then becomes quantity 10 squared. Third, take their difference. It then becomes quantity z plus k squared minus quantity 10 squared. Now, as you can see, quantity z plus k squared can still be solved using another special product, which is square of a binomial. And to solve for the square of a binomial, we should follow the following steps. First, square the first term. It then becomes quantity z squared. Second, solve for twice the product of the first term and the second term. And third, square the second term. It then becomes quantity k squared. The final answer then for the square of a binomial is z raised to the second power plus 2zk plus k raised to the second power. And your final answer for this problem then is z raised to the second power plus 2zk plus k raised to the second power minus 100. That is your final answer for our challenging question.